When you picture wind power in your head, what do you see? I bet it's a field of those huge three-bladed giants spinning away, right? Well, what if I told you the future of wind energy looks less like a propeller and more like a giant piece of grass just kind of dancing in the breeze? Today, we are diving into the Vortex Bladeless, a pretty wild turbine that makes power not by spinning, but by wobbling.
I mean, think about that question for a second. What if you could harness all that wind power without a single blade? This one simple idea challenges like 1,000 years of engineering. The answer could totally reshape how we think about this incredible natural force.
You see, for pretty much all of history, wind power has been about brute force. We build these massive blades to fight the wind, to force them to turn a really complex gearbox. But what if we've been going about it all wrong? The Vortex turbine, it takes a completely different path. It doesn't fight the wind, it literally dances with it. This is the difference between brute force and harmony.
Okay, so how on earth does a simple wobbling pole create electricity? To understand that, we have to look at a physical force that, honestly, engineers usually try to avoid at all costs. And this right here, this gets to the absolute heart of the invention. That wobble isn't a design flaw, it's the entire point. The Vortex turbine is built to harness a phenomenon that, when it's left unchecked, can be unbelievably destructive.
And if you want to see just how destructive we're talking about, here you go. This is the most famous example, the Tacoma Narrows Bridge collapse in 1940. The bridge started twisting and oscillating in the wind more and more violently until it completely tore itself apart. The very same physics that caused this catastrophe is exactly what the Vortex Bladeless turbine has learned to control.
So, let's get into the science of how this machine takes that chaotic, bridge-destroying force and turns it into clean, predictable energy. It really comes down to two key concepts. First up is something with a really cool name, the von Karman vortex street. See, when wind hits a blunt object like this mast, it doesn't just split and flow smoothly around it. It creates these little whirlpools, or vortices, that peel off one side and then the other. Each time a vortex peels away, it gives the mast a tiny push, creating a steady, rhythmic, back-and-forth wobble. But those tiny little pushes on their own, not enough. The real magic is aeroelastic resonance. Think of it like pushing someone on a swing. Every object has a natural frequency it wants to vibrate at. When the rhythm of those little vortex pushes perfectly matches the mast's natural rhythm, the two sync up and bam! Those small wobbles amplify and become big, powerful, predictable oscillations, capturing a huge amount of the wind's energy. Now let's see how all this fascinating physics gets put to work in what is, honestly, a surprisingly simple and elegant machine. The whole design is all about minimalism. It really only has three main parts. You've got the mast, which is made of a flexible carbon fiber that's designed to catch the wind and sway. Then at the base, you have a linear alternator, which is just a fancy way of saying magnets moving past coils, that converts that swaying motion directly into electricity. And finally, and this part is so clever, a magnetic system acts like a virtual spring, adjusting the mast's stiffness on the fly to keep it perfectly in tune with the wind speed. This maximizes the wobble no matter how fast the wind is blowing. You know, the real genius of this design is what's not there. By getting rid of the blades, the gearbox, the bearings, you're getting rid of the most expensive and failure-prone parts of a regular turbine. That means no oil changes, no worn-out gears. It's a perfect example of engineering by subtraction. So now that we understand the how, let's talk about the why. This unique design unlocks a whole new world of possibilities for where we can actually put wind power. First, this is a massive win for wildlife. The tips of the blades on a traditional turbine can spin at over 150 miles per hour, making them a lethal hazard for birds and bats. This mast, though, it just sways back and forth, slowly and predictably. It doesn't slice the air, it moves within it, making it way, way safer for our flying friends. And second, it's quiet, so quiet. Traditional turbines have that mechanical hum from the gearbox and that constant aerodynamic whoosh from the blades. This turbine? It has neither. Its oscillation frequency is so low, it's pretty much inaudible to humans. That means you could install them on rooftops or in neighborhoods without bothering anyone. And of course, let's talk about the bottom line, the cost. Now, while a single vortex turbine generates less power than a giant traditional one, its lifetime cost of energy is way lower. Why? Well, for starters, it's about 50% cheaper to build, requires next to no maintenance, and is super easy to transport and install. Okay, but it's important to be realistic here. This technology isn't designed to go out and replace those massive offshore wind farms. It has a different kind of strength, one that comes from thinking about power generation in a whole new way. Let's be clear. Rotation is just physically a more efficient way to capture wind's kinetic energy. A traditional turbine can capture almost 60% of the energy that hits it. A vortex turbine captures significantly less. We're talking around 30 to 40% of what a regular turbine would in the same spot. But that's not the whole story.
Here's the fascinating part. You have to space traditional turbines really far apart because the turbulence, the wake, from one messes up the airflow for the next one. But with these vortex turbines, the opposite is true. The little vortices shed by one turbine can actually help get its neighbor wobbling. They benefit from being close together.
So what that means is you can pack far more of them into a smaller area. And while each individual turbine is less efficient, the overall energy output per acre of land can be much, much higher. It's a strategy of density over individual size.
And that really just sums it all up. This isn't just a new machine, it's a whole new philosophy. It's about moving away from that brute force model of fighting nature and moving towards a harmonic approach that works with the natural physics of the world around us. Which leaves us with a final thought. As we look for new ways to power our world, maybe the most powerful solutions aren't always the biggest or the strongest. Maybe they're the ones that learn to dance with the forces of nature, instead of just trying to conquer them.